Okay, let's go ahead and get started. Good morning, everybody. Good afternoon, good evening, wherever you're joining us from today. My name is Emily Kloss, and I work in communications at the National Renewable Energy Laboratory, and I also support the Global Power System Transformation Consortium, also known as the G-PST. Today's webinar is hosted in collaboration with Peru system operator COES alongside the Electric Power Research Institute, and today's topic will be on the control center of the future roadmap for Peru's system operator. Now, before we jump in today, I did want to broadcast these directions on the screen once more for those of us who might have just joined a few moments ago. You can listen to this webinar in Spanish, and we have some detailed instructions on the screen here. Essentially, you'll want to click on the interpretation globe on the bottom of your Zoom toolbar and select Spanish, and you should be good. And then we'll also have these instructions in the chat as well. Okay, a few housekeeping items to go over. The first is that this webinar is being recorded and it will be shared with attendees in the days following the event. So as an attendee, you can expect to receive a link to the recording, any resources shared, and also a link to the slide deck. You will be automatically muted upon joining and throughout the webinar. But if you would like to add comments, share input, or share introductions, you can do so by using the chat. And then if you would like to ask questions to our technical presenters at any point, you can do so through the Q&A function, and this can be found on your Zoom toolbar. Please note that we have a pretty lengthy amount of time dedicated to Q&A at the end of the session, so please feel free to ask your questions at any point, and we will be sure to address them at the end. If you're having any technical issues, you can use the chat to message me, Emily Kloss, or Isabel McCann, and we will be happy to help you. You can adjust your audio through the audio settings. If you're having any issues, you can also dial in and listen by phone, and dial-in information can be found in your registration email. And then lastly, we do have a survey that will launch when this webinar ends, and we greatly appreciate your feedback. Okay, so I'd love to introduce our speakers for today's session. First, we have Amy Rose, who is the G-PST Technical Assistance Lead, and she's also a senior researcher at the National Renewable Energy Laboratory. We have Jorge Cabrera, who is a real-time monitoring application specialist for COES. And then we have Adrian Kelly, who is a principal project manager at EPRI. Okay, and with that, I will hand it over to Amy Rose, who will introduce today's webinar topic and also give an overview of the G-PST.
Thank you, Emily. As she said, my name is Amy Rose. I'm a senior researcher at NREL, and I'll be helping to facilitate our webinar today. You can go to the next slide, Emily. So here's our agenda for today. I'm first going to just spend a few minutes providing an overview of the G-PST for those who aren't familiar with it, and how we work with system operators around the world and the type of work that we do, including the type of support you'll hear today with COES on the development of a control center roadmap. And then we'll hear from Adrian Kelly from EPRI on the control center of the future framework that they've developed, and Jorge Cabrera from COES on the Peru power system and their control center roadmap. And as Emily mentioned, we have lots of time at the end for Q&A, and you can use the Q&A function to input your questions. Please do so at any time sooner rather than later, so that we can try to get to as many questions as possible. Can move ahead. But first, just briefly on what is the G-PST, or the Global Power System Transformation Consortium. This is truly a global group that is focused on support to system operators and making sure that they have the tools and the data and the technologies they need to operate a high renewable grid. Who is involved? We have system operators from around the world, as well as leading technical institutions all working together. And the way that we work is through 5 pillars. We call them action pillars. The first is really focused on research for emerging challenges and new solutions that we need to develop to operate a high RE grid, and then peer learning to disseminate those findings. The second pillar where I work is on system operator technical assistance, so helping to implement those solutions. The third pillar is focused on foundational workforce development. Pillar 4 is on localized technology adoption and support. And the 5th pillar is on the development of open data and tools. And I'll talk a little bit about each of these more in a minute. But first, if we go to the next slide. To date, the GPST is partners with 13 system operators across 12 different countries. So we really are going around the globe. And these include our founding system operators, which are in yellow here, as well as support to 7 system operators where we're providing that kind of technical assistance that you'll hear about today with COES. And what kind of assistance do we provide with these countries? If we go to the next slide, it really ranges, and it includes all of those GPST pillars that I just spoke about. So we can provide support on developing specific solutions to enable the integration of renewables, like developing roadmaps to upgrade or modernize a control center, developing tools and visualization capabilities to manage and monitor inertia in real time. We also support workforce development, where GPST experts can partner with local universities and training institutions to develop curriculum, courses, and degree programs with specific modules that are focused on power sector transformation, but also considering the unique needs of the country where we're working. And we can provide specialized continuing education for system operators on specific technical topics as new training needs emerge. Another area where we provide support is on localized technology adoption, such as working with local system operators or relevant organizations to establish or upgrade power electronics testing capabilities to ensure that equipment can be safely and reliably operated, but also focusing on developing standards that are locally appropriate. And we can provide expert input on the development of national equipment performance standards. And a final area where we provide support is in open tools and data for power system planning and analysis. And this spans a whole range of tools that system operators need to plan and operate their system. And none of this can be done, of course, without quality input data. And so the GPST can also provide support in the development of new data sets to be used with open tools. And you can read more about all the pillars of the GPST, the work that we're doing around the world with different system operators at the link below, and also a link in the chat. But at this point, I think I'd like to dive into the topic for today. So I will hand it back to Emily.
Thank you, Amy. So our next speaker will be Adrian Kelly, and he will be talking about the Control Center of the Future framework. But before I hand it over to Adrian, I will give him time to share his slides, and we're going to launch a quick poll question for everyone. So you should be seeing this on your screen right now. Please note that you won't be seeing it on your screen if you're using the browser version of Zoom. Okay, I'm seeing some answers come in. Okay, we'll give it about 15 more seconds or so. All right, so here are our results. It looks like most of your area of work is in DSO, generator, or non-TSO utility. Okay, thanks everyone for participating, and I will now hand it over to Adrian. Adrian, you might be muted if you're speaking.
Is that better? Can you hear me now?
Yes.
Yep, yeah. We can hear you clearly.
Sorry, clicked the wrong button. Thank you to Emily and Amy for the introductions. My name is Adrian Kelly, Principal Project Manager at EPRI Europe. Here to talk a little bit about the Control Center of the Future framework research that we in EPRI have been developing in the last few years, and also just to tee up the presentation that comes after me by Jorge on COES, who we helped to develop their future control center roadmap. So this sort of is supposed to set the context for Control Center of the Future research, pick out some key points and lessons learned that we have gained from working with both the FSOs and other system operators around the world in the last few years. And the aim is to, I guess, trigger some conversation, show what we've learned, and hopefully share some of the lessons learned and point to some innovations that are happening throughout the world. So I start here, usually these presentations, when I'm asked about the Control Center of the Future, we have to set it in the context of the control center of the past, or where we are at present. So I see it as a journey, a kind of continuum across the decades, or coming up to the centuries right now for system operators. So all the time our operational purpose has been to maintain a safe, secure, reliable, resilient, economic and sustainable power system, and also facilitating network development, economic growth where it happens. So that's kind of the key purpose that spans across the decades. It's always been thus, and it will always be thus. But where we started from, if you think about early stage control center or system operations, really you're thinking that the early part of the century. Lots of manual processes to operate the system. So manual switching, the operator is very much acting at real time, responding to impulses and signals, and dispatching and controlling the network in real time. So the gray boxes indicate manual operational processes, and the person at real time with the control at this point indicates the I guess lack of foresight and continuous kind of operation at the boundary. Then flashing forward with the onset of compute power, SCADA, EMS systems, so in around the 1990s, you see a slight evolution whereby you have more processes indicated by the three columns of blocks here. Some of these, there's some element of automation, so you start to see introductions of things like AGC, automatic reclosing, special protection schemes. These types of things that are automating some of the system operator work, but you're still at a mostly manual process throughout. And there's an introduction of software. The operator's perspective has drifted a little bit. They're not as close to real time. They're more kind of in a forecast, looking ahead. They have some forecast information that they can assess and operate the system to. If you think about it, systems today, control centers today, it's evolved again slightly. You see more processes again, indicated by more market systems, more kind of coordination between TSOs and different system operators. So you have more things, you have more processes for the operators to manage. Some of these are automated, indicated by the orange. You have partially automated, partially manual, and then still have some manual processes in control centers today. So it's not a very automated system. The black line indicates architecture. So some of these tools are tied together. So you're thinking EMS and market management systems or outage management systems are tied together, but mostly you have kind of independent software tools working kind of in parallel. Looking forward to the future control center, for 2030 plus in the future, in the next 8 years, what we're hoping to do is, in the context of significant network growth and data growth across the network, what you have is the operator's perspective is shifting a little bit more away from the real-time world to the operations planning world. So you see here they're in the middle of the operations planning, real-time operations kind of time continuum. So they have a foresighted vision of the future. They have forecasted data feeding into their processes, and their action is occurring kind of at real time in an automatic fashion. They have a single customizable view of the network. So all of the system information is feeding into sort of one dashboard or one system here in the middle, indicated in green. And this dashboard is taking information from the automated processes, which are the orange blocks here, and they're fed by the red behind, which indicates data, network, and models. These automatic processes have to have a link to the backup manual processes because automation will break. So when it breaks, the operator has to be able to intervene and indicate and go for a manual fix of it. And finally, the last step in the process is that all of these are linked to a simulator environment or operations readiness environment where your processes and your tools and your systems are all replicated in a digital twin simulator type environment. You have high performance simulator capability here, and this is a kind of triangle where your processes are replicated across the three environments. So this is kind of what we want to strive towards. So architecture that ties together automated processes, fail over to manual processes whenever automation breaks, and then everything linked back to a simulator or what we call operations readiness center. And then the operator's decision support or view of the system is streamlined via an interface here. And they become, in this context, operators or people that work in a forecast way. So they have constant look ahead, good foresight with forecasted data, and they only need to intervene at this level whenever an emergency happens or an event happens on the network. So this is a long-winded way of saying we're on a journey. This is sort of a vision of what we want to get to. And I'm going to spend the next few slides talking through some of the kind of key points around these particular areas. They're all color coded by here, so you'll see the constant color theme as we go. And I also try to highlight some kind of innovations that we've encountered with the G-PST FSOs and also other system operators that we've encountered. So starting at the black level, which is the architecture business capability model, what we're seeing in this context or this environment is three key areas here are around the development of business capability models. So the system operators that we talk to now are they realize that the processes are increasing in scale, in granularity. There's cross-boundary TSO, DSO, upwards and downwards, vertical and horizontal. So developing a business capability model that maps out the processes that your organization is expected to do is a key first step. This business capability model can be used then to build an architecture and assign staff and develop capability and develop people and resources and things like that. So where we've seen this being useful is, well, EPRI have developed a utility reference business capability model that can be used by any system operator, picked up and used. It's a standard out of the box. We also see some good work with AMO, developed a business capability model in the last few years, and EnergyNet, who developed really good close coordination between gas and electric operation. Second step is around modular flexible architecture. So what we're seeing here is a move that companies and utilities, they want more flexibility in their application toolkit for operations technology and information technology. So what we're constantly hearing is like a move towards or a trend towards modularization, the architecture being broken down into pieces that can be slotted in, slotted out, upgraded, and new things tried, all linked together via interfaces, data interfaces. And this always also allows kind of in-house developed tools, which COES will talk about a bit, and open source tools to be developed and plugged in. And the innovations in this space, you've heard from the 50 hertz through GPST, MCCS, modular control center system, I think it is. Maybe someone correct me on that, but they have developed a modular T-bone architecture. CalISO have developed working for many years with an enterprise service bus that sort of links this type of concept here. And the third one is around agility or agile design processes for IT. So instead of having multi-year massive projects that no one's quite sure whether the scope will be realized or if things will be delivered as expected, what people are moving towards in the tech industry and also what that's permeating into the operations industry is kind of more rapid development, fast iteration, flexibility, focus on the customer, which is the operator. So we've seen some innovations here with 50 hertz again, the Estonian TSO Ellering, but more and more we're hearing about these types of principles here. So there are just some key points with some lessons learned. I'm not calling out every single thing we hear here. I'm just trying to give a sense for where there's innovation or where we're seeing it. The red level is around operational data and models. So you can imagine data is going to grow substantially. The network is going to grow, resources are going to grow, etc. So what that's driving is the need for centralization of your model capability. So using SIM for model management, expertise centralized in one group, those models feeding into all of the OT tool systems. Being able to develop model granularity between TSO and DSO, and then automated data transfer, so minimizing the need for copy pasting or manual kind of data transfer, file data transfers. Again, lots of innovation here in the US. CALISO and ERCOT use a very, very advanced SIM model for their model management across all of their systems. NSOE in Europe with the CGMES. Seeing also NGESO with their virtual energy system idea for a digital twin of their data network is pretty advanced, innovative thinking that's developed in the last few years. In terms of model validation, you're seeing, previously we had dynamic models of very large network devices, generators, load, all of that. Now we're seeing the need to do that for battery systems, HVDC, DER, demand aggregation, all of that. So we need these models to be more granular. We need validation of the models post-event. We need processes and systems to continually validate these models and utilize PMUs where we can, high-speed data. So again, looking at AirGrid for their WAM system for model validation and assessment in real time. In the US, again, ERCOT with the Passport project and CALISO with the DER aggregation have done some great work and innovation here. And EPRI also have power plant model validation tools that can do this sort of thing in real time. And thirdly is this move for cloud or data. So what system operators are realizing is that they're sitting on large data lakes of operational market data, and people want access to it, and the technology is there to give people access to it, but there's lots of questions over security and access and things like that. So utilities are moving more towards this use of data stores and cloud-based solutions. So thinking here about EnergyNet, again, very good innovation using their data hub and working with IBM and other partners for cloud development, the NSOE transparency platform, and AMO for development of a connections tool that's open to the wider industry. And this touches a little bit upon the pillar 5 there, which is around that Amy talked about, which is the open data aspects of it. Just moving forward, the third key element was the orange layer, which is around tools, operations planning and operations tools. So we're seeing kind of new tools for new challenges. So system strength is becoming an issue, converter stability, inertia, fast ramping, the duct curve, etc. So that's these innovations on the system are driving the need for new tools and innovations with the software that's used, new markets, and also this kind of level of disruption that we're seeing with new and exciting kind of software vendors that have good offerings for operational processes coming in and being capable of delivering and wanting kind of to deliver, wanting the opportunity to develop and deliver. So thinking here on Linux Foundation Energy, the open source project, which we've heard about with G-PST before. NGSO did inertia monitoring trials. And then COES, COES will talk next to Jorge, we'll talk about Yapana and Organon, which are in-house developed tools for their specific issues. Also the energy imbalance market that CALISO managed, kind of this speaks to the complexity of new challenges and the need for new tools. We also need look ahead forecast capability. So we spoke about the operator being a forecaster, having foresight, but that requires the forecast data to be fed into the operational tools and processes. So demand forecasts, variable renewables, DER, weather forecasts should be fed into what were previously real-time operations tools. And this allows for proactive operation, allows people to see ahead, look across the peak, and make sure that they're secure. So the leaders here, I would say, are EirGrid with their deployment of LSAT, look ahead stability tool, and the voltage trajectory tool, which does voltage management across a horizon. And then the other thing was around automation of manual processes, where we need to move. We talked about automation, but we still have manual processes there. A lot of it is around data reporting, data entry, alarm management, and a lot of these are manual tasks that don't improve situational awareness. So we need to target aggressively these things and try to take away issues and systems that are like just consuming the operator's time without providing any operational benefit. And we see a move towards paper-free environments, automation of systems, and all of these things. Lastly, we're thinking about the human factors elements and decision support. What we're thinking about here is common data visualization and HMI standards. So having kind of the same operational technology toolkit colored in the same way, indicating color using abnormal indications, operational dashboards. So we spoke about hypervision and a single streamlined dashboard for system operation. Again, COES will talk about this with their very, very advanced Pi dashboards. And also want to call out XM in Colombia, who spoke recently to G-PST, who really advanced the field with redesigning their control center interfaces with an emphasis on color minimization. Hypervision is a concept developed by RTE in France, and also the ERCOT famous Macomber map in their control center that shows various different layers and systems based on what's up. The decision support is kind of a move from a world where operators are expected to interpret tables of numbers and data to a world where actions and options are presented to them, potentially optimized, cost optimized, or co-optimized. So they're intended to say there's a problem on the network, and here is the number of solutions, and here is a subset of the best solutions, and here's how you do it. Again, thinking of AMO with their voltage control systems, EirGrid with voltage automation tools here are good advances in this field. And then training uplift. We need new capabilities for training. We need to be able to train operators to be work on automated systems. And we need to be able to, like some of the things we're hearing about is being able to transfer experience between experienced operators and novice operators. In the past, you might have had a slow learning curve where the system didn't change much and you could learn how to operate the system across months and years, but that's not actually the case now. Things are changing so rapidly that we need to have a faster transition for between experienced operators and novices. Also, people are staying less time in the control center. Typically, they're moving out and less fond of night shifts, I guess, and want to do different roles, and we're seeing faster shift turnover in some places. So advances here are AMO's training simulator is very good for this type of thing. This is the last block, I promise. So here we talk about facilities, equipment, and ergonomics, which is the blue block. I talked about this move, so moving from a standard DTS or OTS environment to something that's more akin to an operations readiness center. So making it a kind of ancillary control center where you have a space for testing software and hardware, for training, for installation of all of your tools, not just your EMS. So EirGrid have plans for the control center of the future. AMO, very advanced simulator where they deploy all of their tools and technologies in the simulator. And then the Southern Company in the US, their SHATS visualization center is a very good example of this. For screens and monitoring, moving, instead of having large video walls and small screens, kind of developing levels between that show what the function level KPIs might be to help with operator decision making. So level 1 being your overview video wall, maybe level 2 is a smaller overhead screen, and then level 3 is your desk-based interfaces that were you impact control. So AMO, again, Tenet, Svenska Kraftnät in Sweden have made some good advances here, thinking about a new ways to visualize data. Lastly is around the deployment of new technology. So now voice control technology is becoming a thing. So EPRI have got some trials going on where being able to issue reporting and VR is another example of new technology coming for visualization that we're developing use cases on. And you need this ORC to Operations Readiness Center to test all these new innovations out. So we developed this framework. You can see it here. It's color coded, and all of these elements fit together. All the elements and blocks are fit together, and they're all part of the same framework. Sorry, my just going mad. So what we're saying is there's 5 key areas and 11 pillars that are all associated with these things. And we've been doing some work on these in the background with all of these entities. And we're hoping to look forward to hearing from COES Peru and Jorge and the innovations that they've made. So thank you for that. I'll pass back to Emily and look forward to any questions in the Q&A later on.
Thank you, Adrian. So before we hand it over to Jorge to discuss the Peru's electrical system and also the roadmap, we have one other poll question to launch. So Adrian, if you could end your screen sharing so Jorge could, thank you. And Jorge, feel free to pull up your slides. And I am now launching the second poll question. So you should be seeing this on your screen.
Okay, thank you very much, Emily. I will send my screen. This is you confirm. You can see the screen, please. Okay. Can you see my...
Great. We're almost done with the poll question. I can see your slides. Yes, I can see them.
Okay. Please you tell me when the poll question is already done.
Okay, sounds good. I will give it about 10 more seconds. It looks like we still have some answers coming in.
Oh, it's okay. Perfect.
All right. Okay, I'm going to share the results now. So the question was, which of the 5 areas is most fit for purpose for the future systems? And it looks like there were some close ties, but the largest response was control center and ops planning tools. And thank you everyone for participating. We can hand it over to Jorge now.
Okay, thank you very much, Emily. Okay, I'll put this on the screen. Thank you very much all for this opportunity. I am Jorge Cabrera from the Control Center of COES. I will present you a little resume for the power system of the Peruvian power system, and also briefly scope for the roadmap for the control room of the future, based on the study that have been done with NREL. Okay, well, I have a summary of the Peruvian electrical system. Peru has an energy matrix made up mainly of hydro and thermal. Wind and solar energy are expected to be increased by approximately 1,000 and more next decade. And also by the last year, we got a maximum demand of 7,000 megawatt 173, and also as you can see in the colors of the cycle, you can see that the main source of our energy is hydro and thermal, but also regarding the renewable resources, wind energy is increasing and will have more participating inside the production matrix and also in the operational situational awareness. As you can see in the case of the Peruvian system at the beginning of the year 2004, we started to produce energy based on the natural gas from Camisea, as you can see this in the figure, and we have a very large production of this resource by this year. Also, well, over here you can see the effect of the COVID-19, and our maximum demand by now is around 7,500 megawatts. Okay, regarding our control room, we have a scheme, a work team. We operate and supervise the interconnected power system 20 hours a day, all the year. And we got 3 work shifts, as you can see over here in this scheme of hours. And for the operation, we got operation coordinator, an operation specialist, and reprogramming specialist. The last one is regarding the hydrothermal economic dispatch. And the another ones use all the tools to manage the production of energy of each power plant, and also make the regulation of the frequency and the voltage around all the system. In the case for the tools for the control room, almost in the last decade, we got an explosion for many tools. Some of these tools is from vendors, and another ones was developed in-house. And this is the way that COES manage all the situation in the operation at real time. In the last 5 years, we increased the effort to do more in-house tools because it fits more in the vision and the exigency of COES. For example, regarding the stationary monitoring, we use OSISOFT 5-vision system. We have some application based on Siemens, and also another ones based on Python with a specifically mathematical model. We got the hydrothermal deviation for redispatch, voltage quality monitoring, SCADA Spectrum Power 7 for monitoring all the power system, and voltage stability index for this load bus bar, an intelligent congestion monitoring that analyzes all the grid around all the country every 5 minutes, and we can not only see which value is more than the limit, and more than that, we can see all the profile from the last day and compare which is the trend for the next hour. And also we got the demand monitoring and renewable resources. Most important for us is solar and wind, as you can see in the figure. The another ones is the dynamic monitoring and control. Regarding the dynamic monitoring, we got sub-synchronous resonance monitoring, the one system for frequency and power stability, and Ergonomics for security regions at real time or in real time. And for control, we got the AGC for the secondary regulatory frequency. And for the monitoring and calculation for the short-term market, this is a very special issue for COES at real time, because our market is based on marginal cost, but this cost is calculated at real time with real data and some specific models, some economic model for each power plant. So this beginning with Jupana, which is an economic dispatch model based on vendor cuts, which is being deployed in COES 3 years ago. We got the optimal power flow, in real time and the marginal cost in real time that you can see in our website. So the general vision of COES toward the next decade, we have to improve data management models and tools. We have to permanently adapt the technical procedures and contribute to the regulatory framework and ensure the operation of CCO or control room and economic transactions. So we are looking forward the next decade, and we have this project or this vision to the next year. For example, regarding the Adrian slides, and it's the same scheme of colors, the data architecture, application, and electricity market, we have to design cybersecurity for all the corporate information system, the SCADA, and the over database. I know that the study that we made with the REL make some specific topics in additional of this framework, but by now we are focused in this specific project. In the red one, we got the data modeling. We have the diagnosis of our data, relationships with application and storage. We have to make the implementation of the network model management. This is a vision for the future. We are doing our work to get this project done. And also, we got the model management area, which we have to implement the model management area in COES. We have to promote, develop, and check and update the mathematical algorithms for our in-house tools, intelligent data management, and develops the meter project. The meter project is to get the data from each generator from the metering devices directly. Okay, regarding the SCADA, EMS, and the AGC upgrade, we are doing work with the specific vendor to make the system upgrade and renewal of the equipment and operating system. By now, we are improving our dashboards with the Pi system and also with open source tools like Grafana and Python to manage all the data that we have to control or supervise in real time. Monitoring power system is not only to check frequency, voltage, or the loading for each transmission equipment. We have to check, for example, hydro conditions, the forecasting for solar, wind power plants. We have to check the models, the economical models for each power plant, the availability for fuel, and another variables that we have to implement is hypervision to get an efficient way to manage all these kind of situations. And also for the middle of the decade, we have to implement the hypervision scheme, maintenance, and continuous improvement. And also in the last part, we are focusing in the OTC, the Operators Training Center, which is the way to get a better situation of the OTS room, which was an idea developed with REL. This has not to be only a room, we have to be all a building that have to improve and increase the personnel for the training, deployment of all the control room COES application in the OTC. And the last part of this plan is to training all our operators with all the control room tools. For finishing this presentation with the roadmap that we have prepared in conjunction with G-PST, COES has been able to draw up a vision with a view to 2030, giving a greater relevance to the data management, data modeling, and their corresponding cybersecurity. This has been really satisfactory with the objective of COES for a better management of the wholesale electricity market, which is the main part of the activities of COES, as well for the preparation of the control center for the synchronous international interconnection with Ecuador and Colombia, which is the near future of it. A study like the one show is perfectible, of course, for which future updates will be very useful for the electricity sector in Peru. Thank you very much for your attention. And Emily, please, I give you the control of the presentation.
Thank you, Jorge. Great presentation. So our next segment of the webinar is Q&A, which we will be moving to shortly. So if you have any questions for our presenters, be sure to ask them in the Q&A now. And before we move on to Q&A, we do have one more poll question that we're going to launch. So I am going to share that right now. You should be seeing that on your screen. Share your answers and I will broadcast them shortly. Okay, it looks like we have a lot of responses coming in. All right, I will give it about 10 more seconds. Okay, sharing the results now. So the question was, which of the 5 areas is most in need of urgent upgrade for the future system? And it looks like the highest answer, which was pretty close with all of the above, was operational data and models. So thanks everyone for participating, and I will now hand it over to Amy, who will moderate our Q&A today.
Great, thank you very much, and thanks to Adrian and Jorge for those presentations. As a reminder, you can put your questions in the Q&A box, and we will try to get to as many as we can. But I first want to open with a question to Adrian. So Adrian, you gave a lot of great examples of different actions that have been taken around the world and control rooms to upgrade their control rooms. And I'm wondering, based on your experience, have you seen any control center changes that could be considered low-hanging fruit? So these are low effort but high impact changes that control rooms could do now.
Yeah, the main one I would think about is around visualization or dashboard development. So what we kind of typically see in a control center is the same kind of displays and things that get rolled over from EMS upgrade to EMS upgrade. And if you look at pictures from today with sorry, it's from a video from today's control centers and compare with the the 90s and 80s, they kind of look and feel quite similar. But nowadays you have a lot of really good options for kind of cheap development capability, computer-aided design capability. So Jorge demonstrated a couple. There's lots of kind of free and open kind of tools that you can use for developing dashboards. So I would say that is like moving from a world where you're used to display kind of tables of numbers and forcing the operator to look at that table of numbers and use their experience to judge what's happening, to a world where the number is in a a trend or a bar graph or a pie chart and showing you how loaded a line or transformer is, or what your percentage headroom is, those types of things. So they would be relatively low effort. If you get a whiz kid with design, they can mock you up a good dashboard in a couple of days. and the impact that they have on operators' life is really immense. You know, their situation awareness improves. They're not having to manually kind of think about things and calculate things, and they get the answer kind of there. And also these dashboards can be flexible, they can be extended, they can be changed quite easily. The color coding can be changed. So I put that one as number one. The other ones maybe around alarm management is the other kind of constant bugbear of operators. So you have a couple of options here, like some relatively low effort, high impact ones would be developing monitoring capability on your alarm loads. So first, you know, when you're in a hole, figure out, like, you know, stop digging and figure out where you are. So see how many alarms you're getting on an hourly basis, on a daily basis. What are the types of alarms? Are they chattering? Is there a frequent offender? You know, and these are the things that can only come out if you run it through a kind of data analytics tool. And these are all freely available again and will come with your in-house corporate packages and things. You can do good things pretty easily. So you can stand up a monitoring capability and look at your alarm performance kind of and report on them and tackle your low-hanging fruit. So that's relatively low effort, high impact. If for alarm management for high effort, high impact, you would be thinking about, you know, reprioritizing your alarms and shifting alarms that aren't necessary out of your control centers, but that takes a lot of work, manual, laborious, process-driven, standard-driven work. So I would start with the low effort thing on the monitoring, and then if needs be, kind of delve in and dig in and try to reprioritize the work. So.
Okay, that's great. Yeah, so not necessarily collecting more information, but better use of the information you have so that system operators can better understand it quickly. That's great. For Jorge, I have a question for you about kind of just the process of developing this roadmap with Adrian and his team. What were kind of the big challenges in developing the roadmap? Would you have any recommendations for other system operators who want to do a similar assessment?
Yeah, of course. For the other system operators, been doing a roadmap exactly with G-PST and Unreal specifically is very important because maybe in the time you can be captured by the day working, and maybe you don't see the future and don't do the planning exactly for the tools or for the regular investment. So it's important to do this kind of work to have a great planning, to redefine maybe some work scheme, or to redefine the path to the way that the TSO do the operation, the regular operation.
Great. And then another question for you from the Q&A box, which is, how do you plan the articulation between the COES and the DSOs of Peru? Were there agreements reached to standardize the transmission network model?
It's a very difficult effort, but this is important. For example, in Europe, this is a very challenging issue because they have to manage how to interact the transmission network and the distribution network, and do it in the automated way. Because by now we do this in the coordinated way. The operator from COES make a call, and another one in the distribution system receive the call and coordinate the operation, for example, the regulation of taps for voltage. But in the future, the number of distribution or the number of equipments will be so many that we can do this manually. But this will happen here in Peru, for example, in next decade or maybe next 2 decades. This is a real problem by now, Europe. So the right way to manage this is to talk in the same language, maybe the same language, or use a standard database that the transmission and distribution must to be in accurate. Exactly, it's the the world must be in the same path. This is the way from COES to manage this is to try to standardize all the models since the projects. By now, COES receives the models for the transmission and distribution network in excellent format, and we put this together in the main network Peru. But this is the way that we are been working here by now. But the real-time modeling, this is a future work to do.
Okay, thanks. And for Adrian, there was a question in the chat about how academia could get involved and participate in future plans of the control center. Have you seen any good examples of that? Okay.
Yeah, like if we think about the framework in those areas, you know, so it's not, we're trying to break it down into the specific areas that people could be kind of, you know, kind of everybody can contribute to, you know, so sometimes it might feel like, wow, how do we, you know, the system is changing so quickly, like what do we do? There's so much to do. How do we tackle it, and different systems and data points, all of that. So we're trying to like kind of structure it. So there's lots of areas within, there's lots of things to do within all of those five color coded areas. If you think about architecture, like I think future architecture design, software development, I think that's really up in the air now. A lot of utilities and operators are searching for, you know, the right solution. They're making changes, trying to develop and collaborate. I pointed to a couple of innovative spaces there, but I would say that's the architecture that will be used in, if we have this in 10 years, will be completely different to what we are using today. So that's on the software point of view. From the data and the modeling point of view, you know, there's so much work on data standardization, data management efforts, and also kind of use of machine learning. Kind of, we didn't bring that up, but you know, that needs a lot of big data sets for training and all of that. So that's a kind of key area academia are usually involved in. On decision support, I think of that as optimization, and I think of optimization as a very academic subject in its nature. So, you know, when if you have a process such as voltage control, and your voltage control tool that's managing the process is telling you have an issue and you need to do something, but your action there is going to impact another operational process. Could be congestion management, or it could be, you know, stability management. But one action is coming out of one process. It could conflict with an action in a different process. So how do we optimize or co-optimize those actions to get what the most effective action would be? So nothing like that exists today. Every process, every tool does its work in its own process, but there's nothing really that co-optimizes. So again, key area for academia around decision support. And then kind of technology, I challenge the wider industry and vendors there as well, that, you know, again, we tend to be using the same sort of control center technology, desks, desk screens, you know, keyboards, mouse, but, you know, there's new and more innovative products coming out there. I mentioned voice control, virtual reality. You know, there's lots of different areas that we can kind of, that academics with you know, research budgets and PhD students can kind of tackle, and I have a long list of them. If you want to get in touch, just drop me an email or hit me on LinkedIn, and I can put you in touch.
Thank you. And then we have an interesting question from Victor Meza, and I'm actually going to break it into two types of questions for each of you. And it's, so he says, are you planning to develop your own tools or solutions, or do you consider that the current solutions in the market can meet the roadmap's needs? So for Jorge, I'd like to hear from you about the specific things you'll be doing in the roadmap and what the plan is there in terms of developing your own solutions versus something that's available now in the market. And then Adrian, kind of more broadly, in all the different topics that you talked about in areas where, you know, innovation is needed, if you can identify areas where, you know, we could use existing tools and things exist in the market versus we need to create something new because this capability doesn't exist. That'd be great. So maybe we'll start with Jorge.
Okay. Well, in fact, we are planning to develop our tools, in-house tools, mostly for the specific regulatory needs for COES. For example, the regular tools that there are in the market meets a specific algorithms or a general procedure, but in the regulatory framework of COES and for Peru, we have a variation of this general scheme. So we have obligated to create our in-house tools to meet this regulatory framework. Then also there is another requirements that meets with the vendor solutions. So there is a mix in the future. Maybe for example, for the real-time operations and indicators, in-house tool is mostly the most used. And for planning, analysis, the vendors is most the common way to meet the solution.
Thanks. And Adrian?
Yeah, I'd just like to give Jorge and Alex and team in COES a shout out, like really innovative development of you know, using Python and capability that's free and available to kind of utilize and not wait for market solutions and things. They've developed their own and they work really well for the systems that they have. So so yeah, and you know, they're one of the more advanced operators that we've worked with in this field. The question about like what are the I think there's like lots of space for new, I mentioned it, there's lots of space for new vendors and scientists. Like there's, if you, again, sketching back 10 years ago, you might have had only, you know, a handful of potential software vendors that were able to do operational processes, and now you have hundreds, thousands that can do it and compete. There's open source technology as well that are available, and then there's good software development capability within most system operators. Given the chance and the scope to do something, that can pull things together pretty well. We've got great examples of that throughout. I would say the key, the one that's kind of needed or would be, I think that was your question, Amy, that you know, what would be a really good system or tool was we've been working with RTE and a few other of the system operators around trying to use machine learning, reinforcement learning techniques to be able to kind of manage the grid. So, you know, learning from past operational performance or past operational actions, training it on kind of data sets or synthetic data sets, and being able to develop potentially systems that are able to work in parallel with the operators to kind of manage the system. So would be, you know, your operator is managing your system and monitoring it, and then you have a parallel agent that's monitoring and could be like directing the operator to intervene, that see risks that they haven't already seen. So this is very, very early research, but it's showing some good promise. And again, for academic community or people interested, I think that's a good one for you know, a future world where you had sort of highly automated systems. You need levels of oversight. You need people you need an operator being comfortable working with automated tools and systems and AI-based systems. They have to be comfortable, and the trust element and the security element have to be teased out as well. But yeah, that's kind of an exciting kind of early stage one I would point to.
Thanks. And then we had a question come in through the chat from Gustavo. Can you please comment about backup control strategies? Jorge, would you like to start with Peru's approach there?
Okay, let me check. Don't know exactly what is referred to background control. I don't recognize the topic.
Okay.
I can take that one.
Maybe Adrian, yeah.
Yeah, I can take that one first. Yeah, so I think he might have meant you know, how are backup control centers managed. So I didn't say that in my presentation, but yeah, you will always have a need backups for in case of a emergency evacuation from your main control center. I don't think that will go away. In fact, it'll be it's now part of regulation, you know, rule law basically in Europe and in the US, that you need to have something within 2 hours. You need to be gone from one facility to the other. That's there. What's changing, I think, is that previously utilities and system operators were pretty okay with having one main and then a kind of empty shell backup that was a few miles away, that was used not at all or not very often, only for tests and trials. What I think I've sensed is a little bit of a shift here where operators are kind of using kind of 2 mains, so having 2 control centers active and live and operating or maybe doing different functions, and then they're able to back each other up. So, you know, if one fails, they can absorb the other one pretty comfortably, and you maintain that. And that kind of reduces your risk, whereby, you know, there's, you know, in case you have to move lock, stock and barrel to a different control center, there's a risk that your systems won't stand up or something happens in your commute or your transition. Whereas if you have 2 live, one with capability to back the other up, that risk goes away. So, and that helps with asset utilization as well. You don't have, you know, white elephant assets that are sitting underutilized. You're utilizing your full space as well. So that's the trend. More and more of the utilities are doing that, going from main backup to main. I'm not sure if COES have got any thoughts on that, or is that something similar to you?
Yeah, I didn't recognize the term. The backup control center, of the backup control room. In the case of COES, by now we have a backup control room. I don't have the permission to say where is our backup control room, but also is here in Lima. So here in Peru, we are exposed to earthquakes and tsunamis, so this is a very specific preoccupation, a very specific issue, and we are looking forward to move our backup control center to a low risk, low seismic risk area here in Peru, obviously, and looking for the which is the to move our servers to the cloud and have the capability to move our operators to a specific location and build very quickly a fast response backup control center in, for example, in an earthquake or a tsunami or a social situation. In many ways, we are looking in that way.
Great, thanks. And then we had a question come in Spanish for Adrian on how important is it for the standardization of data and digitization of a company in the electricity sector in terms of the implementation of a business architecture?
Very, very, very important. I would say it's one of our regular topics of conversation in EPRI. So we in EPRI are very big and strong on data standardization, especially using CIM, the Common Information Model. For those not familiar with it, is an industry-wide standard for data management, asset data management, and it's been going for, I think it's 30 years or so, and it's kind of now at it's rising in usage and now kind of becoming ubiquitous. So I mentioned like the US TSOs and ISOs, CalISO and ERCOT do a fantastic job they have a standard, one single model of their system, standardized on SIM, and that feeds various other systems, and they've, one team or managing one model, so you don't have disparate system models and loads of different people managing those different models. You have one area. It's very controlled. So having standard model data and operational data is really crucial. The other real benefit of it is machine learning. So you can't you can try, but you won't be able to be successful at machine learning unless you have a very rigorous data standardization, like high quality, very structured, and yeah, anybody you ask to do that, be it academic or vendor, they'll say you can give them terabytes of data, but if it's not standardized and it's not structured, then it's not going to be useful, or they'll waste a lot of time. So so if you want to digitize your company, and that, I would strongly suggest going down that SIM route, and there's lots of information out there, but yeah, definitely point you in the direction of ERCOT, John Mosley and team there. They do a terrific job. I think they might have talked at GPST before on that. Architecture, yeah, a standard. I used to think that there could be a standard architecture that utilities or ISOs could pick off the shelf and deploy. The more I talk to people, the less possible that might be. It's just because each system has evolved in such different ways, and they use different tools, and there's different laws and regulation and usages, that I don't think a single architecture would fit across, but architectural principles do transfer. So I mentioned modularization and scalability. That's a principle. The enterprise service bus kind of idea that the COES do, that again, that's a principle that could be adopted. But having a kind of a single standard that you can take off the shelf is a little bit more of a longer term thing. I think architectures are probably unique to companies, but I'm open to be challenged on that. I'm not a specialist in the area.
Thanks. And Jorge, we've talked a lot about kind of the technical needs for control center upgrades. And I wanted to ask you about the human side of things, which Adrian touched on a little bit in his presentation. The challenge of kind of retraining staff and retraining them more frequently, hiring and retaining staff, having staff that may need to operate in a new way in the control room with new tools and higher rates of change. What's been your experience with that at COES, and how have you kind of taken steps to change how your staff are trained and operating?
Well, this is an important part for the operation. Remember that it doesn't import that how many tools you have, or how is your data or your modeling. The last decision is always being in the hands of the operator. So this is the core for the control room. The another is a decision support. So in this path, being working on the training is the most important part. In the past, for the case of Peru, we got so many failures in the transmission network, for example, and very not a stronger transmission system. So the operators has been in a continuous training in the real-time operation. But now we have 500 kilovolts transmission lines. We have so many spinning reserve, non-spinning reserve, cold reserve, as we name it. So our operators is not exposed to a failure every time. So we have monthly and by now weekly training our operators, simulating the most critical failures, and not only in the transmission network or electrical scenario, for example, energetic scenario. In the case of Peru, the worst case is that we don't have hydro resource. So we have to start using diesel, we start to use most expensive units, and the congestion or the loading for the transmission network is very different. So this scenario is part of the training. And in the other hand, for the real-time supervision, we have to design the dashboard or the alarms to be clear, very simple, and directly to get the information for the operator, and the operator make the decision to. Because if we design a tool which has so many options and got so many scenarios, and that this is very useful for the planning stage, not for real-time stage. So we have to always be in touch with our operators, asking if they are good with our dashboard, for example, or maybe they want to be more specific with some indicators. This process is very important for us, and this is the path that we are being working on.
Great, definitely an important part. So we have one last question in the Q&A. If you have any burning questions, please put them in now. This one is so from Angel, is the management of electrical assets part of the roadmap of COES? In the case of mining, what updates should we consider? I see there have been a few responses in the Q&A, but is there anything you'd like to add, Jorge?
Well, in this case, don't know if I can respond in Spanish because the question was in Spanish. It's better. Ok. En el caso de COES, en efecto, no tenemos activos con los cuales nosotros trabajemos, aparte de nuestro sistema AGC y el SCADA para realizar el control de frecuencia. Sin embargo, podríamos entender de que la gestión de activos viene a ser toda la gestión de los modelos, aplicaciones con los cuales se basa el mercado eléctrico y las decisiones que tomamos en tiempo real. En ese sentido, para nosotros sí es importante esta gestión respecto a la data, respecto a los modelos con los cuales se trabaja. En este caso, COES el siguiente año está previendo formar un área dedicada exclusivamente a la gestión de modelos, dedicado a la gestión con respecto a pulir los datos, mejorar la data de entrada, la parte de modelos matemáticos, no solamente de tomar la data y procesarla, sino hacer el procesamiento de señales correspondientes, entre otros aspectos técnicos. En el caso específico de la minería, los modelos de carga y modelos dinámicos son un input necesario tanto para la parte de planificación como para la parte de operación. Y en el caso específico de tiempo real, la predicción de la carga a lo largo del día, del futuro cercano, también es un punto bastante relevante, el cual esperamos que en corto plazo ya pongamos en funcionamiento para que esta gestión respecto a la carga de las mineras pues sea algo más dinámico, porque actualmente es una manera reactiva donde se responde ante las variaciones de carga, pero el camino es hacerlo de manera predictiva para poder tener un mejor control del despacho hidrotérmico. Gracias, en este caso es a, si más no me equivoco, César el que preguntó. No, Víctor, disculpen que no haya leído el nombre de quien preguntó, pero de todos modos, gracias.
Thank you. So it looks like that's all of our questions. Thank you all very much for joining today and for those questions. And a huge thank you to Adrian and Jorge for their presentations and for this great discussion. And now I will hand it back to Emily.
Thank you everyone for joining. As a reminder, you will receive a link to recording as well as the slide deck and helper resources shared in this webinar. You should expect that in your email in a few days. And lastly, we do have a survey that will launch when this webinar ends, and we greatly appreciate any feedback you can provide. Thank you everyone for your participation, and I hope you all have a great rest of your day.